In this video, I'm going to talk about the first step for making motion capturing robot. The robot's name is CHOOM, which means dancing in Korean. If you follow this video, you will be able to control one motor by using one sensor. If you follow all this video playlist, you will be able to make a motion capturing robot set. Let's get it started. Have you ever seen this robot? I built and showed all of them. This is a kind of motion capturing. These robots are a simple example. I thought that it could be nice if I make a humanoid robot in this way. The right video is a humanoid robot that I built 4 years ago. You can download all of design files from Thingiverse. Anyway, in order to control this kind of robots, you need to make a motion set which takes a lot of time and energy, like a stop motion animation. If it is controlled by using motion capturing, it will be easy and fun to play with it. The final goal for this project is making two kinds of robots. One robot will be a master robot which has sensors on the body. The robot doesn't have any motors. The only role for the master robot is reading all the angle of its joints and sending the values to the slave robots. Other robots will be slave robots which have motors. They are going to move based on the master robot. In order to make the robots, we need to understand the overall system. I'm going to explain from the scratch. We will test only one servo by using one potentiometer, which will be easy. In this stage, we don't need any extra board but the Arduino. And then, I'm going to use 8 sensors for 8 motors with some extra boards. And then, we will send its data through wireless communication. Finally, we will use 20 motors and 20 potentiometers for the humanoid robot. If you are worried about the source code, circuit, or 3D files, don't worry, I'm going to share everything. Let's get started. The first step. This is the basic overall principle in this episode. How can we get an angle from a joint of the body? One of a simple way is put a potentiometer on the joint. As the joint rotates, the potentiometer rotates as well. The Arduino reads the analog value of the potentiometer and sends the signal to servo motor. This schematic shows how to connect with each component. The parts list is in the below description. The most important thing in this schematic is the direction. The board can be damaged if you put the cable in wrong direction. I used the DuPont cables. I slightly cut the end of the terminal so that it could be tight. Plug the cables like this video and glue it. Here is the source code we will upload. I included servo.h, which is a library. I made a servo instance and attached it pin number 9. Reading analog 0 value and mapping the range from 10-bit analog value to 180 degree. And then write the PWM value to the server. If you don't know how to upload the source code, please visit this link. The first test seems good, but it needs calibration. The potentiometer has wider range than the servo. To fix this problem, I added some code for check the analog value. Now that I can read the analog value, I will check the value when the potentiometer points 180 degree. The value is around 843. On the other hand, 0 degree of the potentiometer is around 113. I put a number on the source code line 13. It means that The limitation value of the potentiometer is from 113 to 842, and map the range of the analog value to angle, which is from 0 to 180. For example, when the potentiometer value is 113, angle is 0. Now that we knew how to handle one joint, we can make this up to 6 joints and 6 motors by using only one Arduino Nano. Next video, we will control more than 6 motors with an extra board, which will be awesome. Thank you for watching. Please like and subscribe. See you next video. Bye.